So they have given a question of 150 volt 4 pole DC shunt motor with 320 lap connected conductors, 0.5 ohm armature resistance, 75 ohm field resistance and 0.04 Weber flux per pole and 250 watt constant rotational loss, draws 24 ampere current from the supply. Then under such conditions estimate the speed in RPM. Okay, what they have given, that supply voltage is, this is a DC shunt motor, this is a DC shunt motor, this is RF is 75 ohms, RA armature resistance is 0.5 ohms. This is the motor. Supply voltage is Vs is, this is EB, voltage across this EB. Supply current they have given as IS is equals to 24 amps. Now since Vs is 150 volt, Vs is 150 volt, so what will be the voltage across, what will be the current flowing in the field winding? Please tell.
2 ampere.
Clear, 2 ampere. So what will be the amount of current going through the armature? Apply KCL at this point.
22.
22 ampere, very good. Now then calculate what will be EB under such conditions. What will be EB?
Sir, 139.
How much?
139.
Okay, that is 150 minus 22 into 0.5, that will be 139 volt. Now they have asked speed under such conditions. So you know EB is P phi n z upon 60A. So what is the value of, since it is a lap connection, A equal to P, so it reduces to phi n z by 60. Phi they have given as phi they have given as 0.04.
04.
N we have to find. Z is 320 lap connected conductors upon 60, that is equals to 139. Solve this. What is value of N? Hold on 1 minute, let me bring my calculator.
Okay.
What is value of N?
Sir, 651. Sir, 651.56.
Okay, 651.56. So round out, n is equals to 650 to rpm. Okay. Now they are asking estimate the gross torque. Okay, next part is what is estimate the gross torque.
Sir, we can apply here torque formula, electromagnetic torque.
Yes, yes. How will you apply? Tell me.
Sir, T is equal to
Hmm.
phi Z I A
Huh.
P
Huh.
divided by 2 pi A.
Yes, yes. You can do that thing also, but uh, um, instead of remembering any formula, last time I told you, back EMF is known to you. Huh?
Yes, sir.
Back EMF. Wait.
Yes, sir. P is equal to T into angular speed.
Hmm. Wait, just a second. Let me arrange these questions. Huh. Okay. Estimate the gross torque. That means the torque which is feeding both the frictional power loss and windage power loss and the shaft power both. So total there, that means total torque produced they are asking. So what is the total power produced from the armature? That is EB back EMF into armature current. Yes or no?
Yes, sir.
Yes, sir.
So EB is 139, your IA is 22 ampere. So what is the total power? 139 into 22, 3058 watt. Okay. So what will be the gross torque? Let me call it TG. Will be P by omega. Omega, you know, P is 3058. Omega is 2 pi 652 by 60, that will go above. Okay. So what is the answer?
44.78.
Right. What happened? Okay. 44.78 Newton meter. Okay. Now estimate the shaft torque. This is completely available here at the armature. Now after there will be some friction and loss, that they have given as something as 250 watt. What you need to do it? 250 watt. Okay, 250 watt. These both friction and windage loss, that will be called as there can be constant loss. So what you will do to estimate the shaft torque, T shaft,
Just we will
T shaft torque,
minus.
that will be total power available 3058 minus the losses 250 upon 2 pi into 652 by 60, 2 pi n by 60. What you get? Please tell.
Sir,
41.52.
2808. Hello. Hello, hello. Hello.
What is the answer?
Hello.
41.52 Newton meter.
I think sir is not able to hear me.
Are you getting this?
Yes, sir. It is close but not exact. Sir, I have 41.52.
Hello, sir.
Hello?
Hello.
Hello, Deepak? Neeraj?
Yes.
Hello? Can you hear me?
Yes, sir, we can hear you. Can you hear us, sir? Hello? Hello?
Hello. Sir is not able to hear us.
Hello, Deepak? Can you hear me? Neeraj? Hello?
Hello.
Hello?
Hello. Hello, sir.
Hello?
Hello.
Hello? Hello?
Hello.
Are you able to hear me now?
Yes, sir. Answer you.
Yes, I am able to hear. That's why I'm responding.
Okay.
Okay. So you can see my screen?
Yes, sir.
Okay. So we were there at estimate the shaft torque in Newton meter. So you understood now, we have to subtract the constant loss from the machine, uh, from the total power which is developed, that is uh, EB into IA. From that we will subtract the constant losses, and then we will get the shaft power. Then we will divide it by the angular speed, and we will get the shaft torque. Now they have asked estimate the efficiency. Okay.
Sir,
Yes.
in this case, we can also calculate the torque which is feed to the losses, rotational losses,
Ah,
and then
yes, yes,
minus
yes,
that.
yes, yes. But listen, you can do it. You can do like that also. Okay. Now they've asked estimate the efficiency. Efficiency is output power by input power. Okay.
Sir, it is coming 78%.
Okay. Let me check. Output power is, that is which is available at the shaft after subtracting the losses. So this is minus 250, that is output power is 2808. What is the input power? Input power is 150 into 24 amperes into 100. What is, okay, right, this is 78%. What about Neeraj? Are you getting the same? Neeraj? Hello, Neeraj?
Yes, sir.
Are you able to hear me?
Yes, sir.
You guys had some network issue, and I had to again log in back and do it. Now fine.
Yes, sir.
Okay. Efficiency, please calculate the efficiency. Efficiency will be output power by input power. The output power will be the uh, shaft power, that means EB into IA minus losses, and input power is the power which we are getting out from the supply. Okay.
Sir, EV into IA is the armature power,
Yes, yes,
including losses.
including losses. But since efficiency is output power available at the shaft divided by the input power. See, someone, please, I think so. Your mic is turned on and you are just breathing therein. Okay, fine. Input power will be this, and output power is what you do for output power, but that is whatever is available at the shaft of the machine, that is ready to drive the load, or you may say power available for the load. That will be your output power always. So, like we have, let me explain you the flow of power. There is we have a stator. Okay, we are giving supply to this stator. Stator is developing some magnetic field, so parallelly this is feeding to the armature. Okay, then stator is developing the magnetic field for the armature, that is phi. Now there will be some iron loss here, some whatever resistive loss, all copper loss will be there. If they have mentioned, then if a stator of a DC machine is properly designed, we have very minimum this iron loss. Then in armature again there will be some copper loss. Well designed armature will have minimum iron losses. Then after that this armature power will have some friction loss, some when the rotor will start to rotate there will be some uh, windage loss. After subtracting all this is input power. After subtracting this loss, this all, then power is available, that is output power or shaft power in any machine, whether it be DC or induction or synchronous, anything. This is the flow of power. Okay, any doubt? Hello, hello.
No, sir.
Okay, please we'll start with the next question. Now they have given a no load 250 volt DC shunt motor draws 6 ampere from the supply and runs at 1100 rpm. Armature resistance is 0.7 ohm. Field resistance is 125 ohm. The motor is drawing 72 ampere while loaded. So they are asking estimate the speed in rpm under this load. Okay, the at no load, if suppose there is no load to the motor, where is the input power going? Can you reply this?
Sir, friction losses.
Huh? Or I may say that is feeding the constant losses, friction, windage, xyz. Okay, all sort of losses. Huh? So constant, that are categorized under constant losses, or you may call as rotational losses. And so machine is under no load. Please mute yourself.
Hello.
Please mute yourself. Yes, yes, any doubt?
Sir, under no load, machine is starting running. Is start running.
Yes,
So that is also loss.
yes, yes, please ask.
Sir, when we apply the supply to the machine,
Yes,
that will start to rotate.
yes.
So, sir, that is also loss.
That's what we are saying. Na? There, it will be supplying or feeding for the rotational losses when there is no load on the machine. That means input power is getting dissipated as the rotational loss. Supply voltage they have given as 250 volt. Field resistance RF is 125 ohm, and machine this motor is drawing 6 amperes. Okay, so field is, this is shunt machine, so what will be the field current? What will be the field current?
2 ampere.
Sir, 2 ampere.
Okay, what will be armature current?
4.
Okay, so what will be back EMF?
So 247.2.
239.
247.2. Okay, now they've asked estimate speed in RPM under this load. So at this speed, at this value of back EMF, the machine is running at 1100 RPM. Okay, now let me call this as EB no load. Now what will be EB full load? Huh? They have told that machine under full load is drawing, under full load machine is drawing
72 ampere.
72 ampere. So so 2 ampere will be constant. So now armature current will be
70.
70, right, 70 ampere. Okay, so again find out what is value of EB.
201.
7 7s are 49. That means 201 volt. But this we have to calculate NFL full load. So you know this field current is
Fixed.
fixed. So that means flux is
Fixed.
So we know EB is proportional to phi n, k phi n, proportionality it is phi n. So we can write EBNL, and phi is constant. So we can call that EB is proportional to speed and no load. So let me write directly the proportionality. EBNL upon EB full load FL is equals to N no load upon N full load. So EBNL is 247.2 and EB full load is 201, and this is 1000 RPM, 1100 RPM. This you have to calculate, find out.
Sir, 1352.
No, check once. I have calculated, my calculator is showing 894.4, and obviously under no load speed of the armature will reduce. If you remember, I told you. Check once.
Okay, sir.
Check your calculation. This is simple proportionality.
Yes, 894.4.
Okay, what about Deepak?
Sir, same.
Okay. Please turn off your mic because I am constantly able to hear your breathing noise. So recording will become bad. Okay. Now they have asked estimate the load torque or shaft torque. So the same story in initial cases they had already given that no load losses are, that's why it coupled these questions together. They have given that 250-watt constant losses. Here they have mentioned in this question that no load, that means the no load power is going as constant loss. Then find out no load losses. No load losses are again EB into IA, that is back EMF was 247.2 into IA was 4 ampere in under that condition. That is, let me write more precisely, EBNL into IANL. So what is the value? Okay. Getting this or not?
Yes,
Okay. Now underloaded condition. Underloaded conditions. Gross power developed is when I say gross power developed, I mean armature power developed. So that will be EB full load into IA full load, that is 201 into 70. What is that value? Getting or not?
yes, sir.
Now shaft power will be equal to gross power minus no load losses.
Losses.
No load losses. So that is 14070 minus, so that is 13081.2. The same story, you need to get torque divided by the full, no load, so I mean full load speed. Divide and let me know what is the answer. What is the answer?
Sir, here we cannot take no load speed.
No, they have asked estimate the load torque or the shaft torque. Already it is given load torque. Load torque will be under the, then you need to consider that speed under loaded conditions. Getting or not?
Okay, sir, 139.7.
What you are getting?
139.
139.66.
Yes, sir.
Neeraj, are you getting the same? Neeraj?
Yes, sir, I am calculating, sir.
Okay, calculate. Let me also verify.
139.6. Yes, sir.
Okay, then fine. So these were some questions based on shunt machine. Now we will deal with some questions based on the armature reaction in DC machine. Before I start armature reaction, let me give you some brief.
Yes, sir. I want to know about it.
Yes.
Yes, sir. Armature reaction is what I did not understand yet.
Okay, I will explain you. Wait, listen carefully. Okay. Let me consider a two-pole DC machine. Okay. Hmm. Let me consider single turn winding. Let me consider that this is north, this is south. So current should we make here dot or cross? Tell me. Tell me, will there be a dot here or cross here?
So cross.
Sir, cross.
Where? Left hand side, here will be dot or cross?
Cross, sir.
Okay. Here will be dot. Okay. If this pole is south, where will here be dot or cross?
On the right side dot, left side cross.
Fine. This is the field winding. Now,
Sir,
yes.
here how we are saying that
uh, you know that
dot and cross. Yes, sir, thumb rule I know.
right hand rule. Huh?
Okay.
Rule. See what is happening. Let me explain in detail. I said this is North Pole. Okay. That means direction of field is this. So if I wind, right hand thumb rule, curling down, this is the direction of current. This is direction. If can you see me in camera?
Yes, sir.
This is my right hand, and my thumb points towards the direction of current, and my fingers curl towards the magnetic field, or vice versa also is possible. This will point towards the current, this will point towards the current, and this thumb will point towards the magnetic field. So let's say this is the direction of magnetic field. I shown the direction of magnetic field as top to bottom. So my for uh, the direction of current to establish such a field should be, that means current should come out from this plane and enter into this plane. Come out means dot representation, and getting into the, that will be cross. That means this is coming out, this is coming, windings are wound like this. Understood?
Yes, sir.
See, if direction of current is like this, that means current is coming out from here and going into this. Since we are showing 2D representation, so let my if my fingers will show towards the direction of current, then my thumb will show the direction of magnetic field established by the flow of such a current. Fine? Getting or not?
Yes, sir, fine.
Okay.
It
So
is fine.
now if this is the magnetic field, direction of magnetic field is, let me call this as F. When I call F, I mean main field. Main field means stator field. Okay. You know na that brushes in a DC machine are kept. If this is the magnetic axis, if I call A dash as the direction of magnetic field, if I ask you what is the magnetic neutral axis, then this will be perpendicular to the direction of magnetic field. Can I call this as MNA, magnetic neutral axis? Yes or no? Any doubt? Getting or not?
Sir, why it is perpendicular of main field?
See, if I ask you, these are the magnetic field lines. Huh? Okay. Yes or no?
Okay, okay.
If I ask you to define the magnetic neutral axis, how will you define? This is the direction of magnetic field. This is direction of magnetic field.
Okay.
That will be obviously a perpendicular to the direction of magnetic field.
Neutral axis.
See, why I call it a neutral axis, I will explain you. See, how this magnetic field is getting established. You know how is it getting established? This field is getting, when we will, the current will flow like this, then field lines will, how will the field lines go? Let me explain. Field lines will come out of this. Let me say this is at the south pole. Field lines will go like this. Huh? Yes or no?
Yes, sir.
So if I draw a plane perpendicular to this, then number of, Ampere circuital law or not? If I draw a plane perpendicular to this like this here, so, and try to see the number of field lines going into the paper and coming out of the paper. If a plane will be drawn, so the number of field lines which will go here, that will come out here, and net along this perpendicular surface, net into and net output out of the paper, net into the paper, net out of the paper will be 0. Yes or no?
Okay.
So that can we call it,
Yes, sir.
a magnetic neutral? There is no presence of magnetic field if we draw a perpendicular plane surface, because number of dot and number of cross, this is going this way, let me call it as a dot magnet dot, and here it will be cross. So number of dot will be equal to cross, so it will be a magnetic neutral axis. For now, try to understand that magnetic neutral axis will be perpendicular to the field direction, right or not?
Yes, sir. And sir, there is no field.
Huh. Net field is 0 in that plane.
Okay.
Okay, now for this, for a two pole machine, this MNA will be equal to geometrically neutral axis. Brushes are always placed in GNA. Why in GNA?
Sir, GNA or MNA?
For this machine is not loaded now. Machine is unloaded. Therefore, IA is almost equal to 0. So let us consider some conductors. Brushes are placed along the in geometric neutral axis, or let me call it placed in magnetic neutral axis to collect the maximum EMF developed. Okay. So under no load condition there is no armature field. What we have? Only we have only armature field. Okay. There is no current flowing in these conductors, so there is no armature field now. But when machine will be loaded, what will happen?
Sir, this is ideal condition where machine is unload,
Unloaded.
IA is 0.
IA is almost equal to 0.
But in practical, there will be some current.
Yes. Now I am saying the machine is loaded. Machine is loaded. So now tell me, if I consider that my armature is my armature is rotating like this due to the prime mover. Let's say the prime mover is rotating this armature in this direction. So the conductors under the north pole and about the conductors in the south pole, which will have dot, which will have cross? Please tell me. What will you use here, Fleming's right hand rule? Tell. As per the Fleming's right hand rule, what will be the nature in the upper half? Will be dot or will be cross? Deepak, Neeraj,
Yes, sir.
what will be the conductors? Will the conductors in the under the influence of north pole show dot or cross?
So conductors under the N pole. So dots, sir. No, sir. Cross. Cross, sir.
Confirm. Please be confirmed. What, Deepak? What is your answer?
Final answer, sir.
Sir, I
Cross.
am not able to imagine.
Why you are not able to imagine? Huh? This is a conductor. Okay. Magnetic field effect on this conductor is this. This conductor is moving this way. So let me consider this is some, at this point the tangential velocity is this, conductor velocity is this, B is this. So what is the EMF? Right hand thumb rule, you know, Fleming's right hand rule. This, see in the figure, see in my how I am demonstrating this. If this is my right hand, so the this pointing finger will show magnetic field. This thumb will show velocity or the direction of motion, and then the middle finger will show the direction of current. Okay. So,
Okay, sir.
so this conductor is see, this is B and sorry, this is B, this is V, so the current will go into these conductors. So I will show here by cross.
Sir, it will go outward.
In the upper half,
Sir. Yes, sir.
no, it should go inside. In the second half, it should leave. The conductors under south pole influence will will have current coming out of the paper, and conductors under the influence of south north pole will have current getting into the paper. Not able to imagine. This is once again see in how I am try to see my photo. This is direction of force, this is direction of or force or velocity or direction of motion, and this is my magnetic field direction. Okay, and this will be the direction of current. So see, B is down, okay, but this is moving, this conductor is moving this way, so current direction will be inwards. Inwards means cross. Getting or not?
Yes, sir.
Okay. So upper half of the conductors will have cross and lower half of the conductors will have dot. So now we are having something like this. So we are having something. Now just imagine this is the conductor, forget about the field. These are the conductors, these are having cross, these are having dot. So what will be the nature of magnetic field developed under such condition? What will be the nature of magnetic field developed under such condition? I am saying this is a piece of metal, cylindrical metal, in which conductors are embedded like this. Here current is going here into this, and the second half of the current is coming out of here. Okay, so what will be the nature of magnetic field?
So from left to right.
You mean to say this way?
Yes, sir.
Are you sure?
Yes, sir. No, sir, no, sir, no, sir. It will be opposite, sir.
It will be this way. Why? See, again, the direction of current is inward. Huh? Direction of current is inward. This thumb rule is more than sufficient if you understand this combination. This sometimes these fingers will point towards current, sometimes this can be used as B. You can interchange both. They are orthogonally connected. So if current is going this way into the system and coming out, so magnetic field across this conductor will be, current is current is going this way, so magnetic field developed will be, sorry, magnetic field developed will be, so this way it will come out. End of the day, the let sorry show you properly. Only two conductors I am showing. This is cross, this is dot. Okay, for this into the paper, magnetic field lines will be
Clockwise.
this way.
Yes, sir. Anti-clock.
This way. So you can see with set of one coil, we are getting field like this. So all these are identical set of coils. So net field will be pointing towards this direction. Clear or
Oh,
not?
yes, sir.
Okay. That means under loaded condition, under loaded conditions, we have current here. Now let me call this as F, let me call it as FA, as armature flux. Okay. Net armature flux will be this. Now machine is loaded. We have two flux. One is field flux. We have field flux, also armature flux. Now if I ask you what is the net flux experienced by armature, then this will be the vector sum of these two fluxes. So this is field flux, this is armature flux. So net flux will be vector sum of these two fluxes. Let me call this as Fr. This is resultant flux. So our resultant flux will be like this. This will be Fr. Okay.
Okay, sir.
So initially under unloaded condition, the flux was under unloaded condition, the flux lines were going like this. For the armature. Okay. Now what will happen? This effect of armature will cause, see, now flux line will start like this. They will come from here, go to the armature, and in flux lines were, this will cause concentration of flux on the, this is generator, so I will call this as trailing pole tip. Trailing pole tip. This will cause concentration of flux on the trailing pole tips under generator action, and leading pole tips, if this will, if cross are considered same here, then the if it is a motor will rotate this way, then the direction of our effect of armature reaction will be such that there will be concentration of flux on leading pole tips. So let us consider for the generator action only. So now you see that initially flux lines were completely straight, moving from north pole to south pole. Now some effect of armature reaction is that the field is concentrated on this pole tip and south pole tip, like that. And if brushes if brushes now, okay, now I told you na what initially under unloaded condition MNA was magnetic neutral axis was this. Now resultant field is this. I told you MNA will be perpendicular to the resultant field. Now your MNA will be shifted such that this is 90 degree. Okay, getting or not?
Yes, sir.
Initially MNA and GNA geometric neutral axis were coinciding. Now geometric neutral axis is here where brushes are placed. Now under the load conditions our direction of field flux, resultant field flux resultant armature flux has changed. Due to that now our magnetic neutral axis MNA has shifted in the direction of this is the direction of rotation, this is the direction of rotation,
Yes, sir.
and our magnetic neutral axis has shifted in MNA has shifted in direction of rotation. So for the generator when under loaded condition the magnetic neutral axis will shift in the direction of rotation, and for motor action the magnetic neutral axis will shift opposite to the direction of rotation. Okay.
Okay,
Okay.
sir.
So this is the problem. Now how to get out of it, what are the bad effects, huh? So again if we shift, I told you the brushes are placed upon in the magnetic neutral axis. Up now under unloaded condition we place the magnet brushes here. Now we need to shift the brushes, that is called brush shift to avoid problems in commutation and collect maximum EMF. So, but now what is the disadvantage of brush shift? Why brush shift is not the possible solution? Can you tell anyone? You might have gone through the lectures of sir. So, can you tell me why shifting brush is not a viable solution?
Sir, with varying load, their magnetic location of the MNA will vary, sir.
Yes, exactly. Change of load or mode of operation. Suppose this machine is operating as a generator, you have kept in certain position. When it is becoming a motor, then you need to shift again to the another position. And again, how much armature current we are drawing, that means the loading, depending on the loading condition, that shift in the magnetic neutral axis will vary. So you cannot always track the load current and shift the brushes accordingly. So this is not. So what is the solution? Solution.
Sir, additional series windings, compensator windings, interpoles.
Okay, yes, right. So solution is पहला interpole. What is interpole? We have narrow poles in the interpolar region. We have narrow poles in the interpolar region that will cause cancellation of, they are placed such that the polarity in the poles, magnetic polarity in the poles is assigned such that they will cancel out the armature mmf, okay, or armature flux. So what we will do, so you saw na that armature flux is fa is this way. So interpoles are narrow poles, long narrow poles with polarity of the incoming pole under generator action and outgoing pole in the motor action. What do I mean by saying that polarity of the incoming pole? That is, if we are rotating this way, the incoming pole is south, okay. So polarity of interpole under this condition, when it will be operated as a generator, should be south, okay. And here incoming pole is north with respect to this pole, this interpole, the interpole 1, this is interpole 2. With respect to interpole 1, incoming pole is north campus, sorry, north campus, I mean north. So this will be this. So this interpole will develop a field this way, I will call as Fi. If we decide the suitable number of turns, then to completely cancel out armature reaction, so what will we be left with? We will be left with only the main field, that is Ff. Getting me or not? समझ में आया?
Yes, sir. Please ask Deepak if he is following or not. He's
Deepak,
quiet.
hello,
Yes, sir.
any doubt
Hello.
in this?
Yes, sir. We are totally canceling.
Yes. Are you able to understand what I am saying, or should I speak in Hindi? Please respond so that I can explain you better. Okay. You understood, Neeraj, what is how interpole is working?
Yes, sir.
Okay. Now we have another part, that is compensating winding. So this interpole will cause cancellation of flux in the interpolar region only. So compensating winding, how is the compensating winding? Compensating windings are embedded in the pole, in the field poles, such that suppose we had na, when machine was rotating, when this was north, this was south, then above set of conductors were cross, then compensating windings are embedded in the pole. There some slots are cut in the pole. So what we will do, if this is cross, so we need to have dot here. So windings will be placed such that they will have opposite nature with respect to the armature conductors. Suppose there is cross, so here it will be dot, so that it will nullify the effect of armature flux directly for the conductors under the corresponding pole. समझ में आया? अगर ऊपर वाले कंडक्टर्स में इधर इधर लेट से ऐसे मूव कर रही है मशीन, तो हमें ऐसा करना है कंपनसेटिंग वाइंडिंग के को कि उसके ऊपर के कंडक्टर्स अगर क्रॉस डेवलप कर रहे हैं तो ऑब्वियसली अगर कैंसिल करना है तो हमें जो कंपनसेटिंग वाइंडिंग के कंडक्टर्स हैं उसमें डॉट फ्लो करानी होगी। और इधर अगर नीचे, सॉरी ये एक चीज़ मैंने गड़बड़ किया और किसी ने पॉइंट नहीं किया, this will have dot, so the nature of conductors, sorry, the current in the conductors embedded in the south pole will are needed to carry current into the pole, into the paper. Clear?
Yes, sir.
Okay, so we'll try to understand by this question. By this question you will have some clarity. Have you already solved this question?
No, sir.
Brush shift.
It was not visible properly, sir.
Okay.
It is a small fonts.
Yes, I'll have it right now. Visible now?
Yes, sir.
Okay. A two-pole separately excited DC generator has full load armature current of 28 ampere. Okay, full load armature current of 28 ampere. It has 128 lap connected conductors. Estimate the demagnetizing ampere turns per pole. Demagnetizing ampere turns per pole if brushes are on GNA. What do you get by this? This is a two-pole machine. The brushes are on GNA. Okay. Then I think estimate the demagnetizing ampere turns per pole. So suppose the armature if machine is rotating, let us consider machine is rotating. Here we had considered at exactly at this position. So if this is the field flux F field, so armature, let's say armature flux is pointing this way. If armature flux is pointing this way, FA, so can I resolve this armature flux into two components?
Yes, sir.
One will be this way, okay, let me, this is not a best way. let us consider armature fluxes this way F A. So it will have two components. Let me call as F cross and F demagnetizing. Why demagnetizing? See, direction of flux is opposite to field flux. So this will cause reduction in the field flux, and this is this perpendicular component will be called as cross magnetization. This is directly demagnetizing, this is cross magnetizing. Okay.
Okay, sir.
Okay, now let us see what they have told. A two-pole separately excited DC generator has full load armature current. It has 128 lap connected conductor. Estimate demagnetizing ampere turn per pole if the brushes are on GNA. We have not moved the uh, brushes to meet as per the shift in the MNA. Machine is loaded, but brushes are as it is. So if brushes are as it is, so if this is the direction, this will be cross cross, there will be dot. So under such condition, flux will be developed this way or not? Just now I discussed.
Yes, sir. Yes, sir.
So if field flux is this way and my armature flux is this way, we do not have any demagnetizing flux. It is only the armature flux is totally cross magnetizing. Can I call armature flux is totally cross magnetizing. So our answer to this will be 0. Now it will be more clear in a while. Now estimate the cross magnetizing ampere turn per pole at full load if brushes are on GNA. We have seen that demagnetizing ampere turns are 0. What is cross magnetizing ampere turn? First, ampere turn per pole, cross magnetizing. That means they are asking total armature flux, because there is no shift in the brush. There is no shift. They are told that brushes are still on the GNA. There is no shift in the brush. So how will you calculate? See,
Sir,
let me call
the ampere turns developed by the armature.
ampere turn will be, first let me turn will be Z by 2. Okay,
Yes, sir.
per pole
Yes, sir.
divided by P. Okay, then current in, since parallel path है ना, current in that winding will be IA by A.
Yes, sir.
Yes or no?
14.
So what will be the
Yes, sir.
calculate?
Four, 4, 8.
That is Z, how much they have given?
128.
128 into 2 into pole is 2 into current is 28. This is 2. What answer are you getting?
448.
Fine. Okay. See, now next part will be understood or not?
Okay, okay, sir.
Okay. Now next part you will be able to understand what is the effect of brush shift. Please write turns, ampere turns. Okay. Now they have told estimate the demagnetizing ampere turn per pole if brushes are shifted from G and A by 5 degree. 5 degree electrical brushes की shifting कर दी गई है along to in order to collect the EMF and ease out the commutation process. So try to understand. We need to calculate how many turns are there in that 5 degree that are causing demagnetization. Let me now they are saying brushes are placed here now. Let me consider this as 5 degrees. Okay, 5 degree electrical. Now it is a two pole machine, so theta electrical is equals to theta mechanical into P by 2, and since P is 2, so theta electrical is equals to theta mechanical.
Yes,
Yes or
sir.
no?
Yes, sir.
So this is again 5 degree, this is 5 degree by the angle properties. Okay, so initially brushes were here, so entire conductors ranging from this position to this position and from here to here, what they were doing, they were causing cross magnetization. Getting or not?
Yes, sir.
Now I have removed that. Now these many conductors, the conductors under this shifted position will account for demagnetizing ampere turns, and the conductors which are left here, they will account for cross magnetization ampere turn. Try to visualize this. Are you able to visualize? So what I will ask, estimate demagnetizing ampere turn per pole at full load if brushes are shifted from GNA by 5 degree. I will call this as, let me call demagnetizing ampere turn per pole will be equal to Z by 2 if I assume that all the conductors are uniformly placed along the periphery of this armature. So total number of turns per pole will be this much, yes or no?
Yes, sir.
Okay. Then if this is beta, this is again beta, then we have total 4 beta
Yes, sir.
electrical divided by 360
360.
degree. That means these many conductors, this is 2 beta E, this is 2 beta E. So these many conductors fall under this effect of brush shift, yes or no?
Yes, sir.
And IA by A remains as it is, So calculate, Z by 2 is 128 by 2, number of poles is 2 into 4 into 5 degrees by 360 degree into 28 by 2. What is the answer?
$49.77.
49.
Yes, sir.
I am getting 24.88. Check once.
Okay, sir. Yes, sir. 24.88.
24.88 na? Okay.
Yes, sir. Sir, I have one question, sir.
Yes, ask.
Sir, when the current starts flowing in the armature conductors, it will deform the field.
Yes.
Yes, sir. Then, even though the brushes are not shifted, the direction of the induced EMFs will change, sir, according to that deformed field.
Yes. No, no. See, in direct nature of EMF will not change. The
Sir, direction, sir.
amount of induced EMF will change. Like the conductors which will be under the concentration of a good amount of field, they will have higher EMF induced, and the conductors which will be I mean the field distribution across the periphery of the armature will disturb. So all the conductors will not have uniform EMF induced. So when the brushes will be commutating, there is a possibility that some amount of rotational EMF is still available in the conductors undergoing commutation due to the non-uniformity of magnetic field. You are able to understand. That's why we see that some spark is there for a poorly placed machine, for poor machines in which we have not exactly a good compensating winding or interpole. We have high amount of spark due to that only. समझ पाए क्या बोला मैंने? मैं ये कहता हूँ कि यूनिफॉर्म फील्ड नहीं रहेगी, ठीक है। अब सुनो, क्या होगा कि अब इधर वाले जो कंडक्टर्स ऐसे होगी ना मैग्नेटिक फील्ड, मैंने अभी बताया,
हाँ सर।
अब मैग्नेटिक फील्ड ऐसे होगी तो पोलैरिटी ऑफ इंड्यूस्ड ईएमएफ नहीं चेंज हो जाएगा। अब क्या है कि पोलैरिटी तो इंड्यूस्ड ईएमएफ की सेम रहेगी, लेकिन इधर वाले में ज्यादा ईएमएफ रहेगा, समझ रहे हो?
ओके सर।
तो इधर वालों में कम रहेगा। ऐसा ये जो नॉन यूनिफॉर्मिटी है उसकी वजह से, सिंस ब्रशेस सिमेट्रिकली प्लेस्ड होते हैं, तो यूनिफॉर्म अगर फील्ड रहती है तो आर्मेचर के रोटेशन के हिसाब से जो ऐसे हम प्लेस करते हैं कि अब जैसे ही कंडक्टर्स चेंज होंगे, जो कंडक्टर्स पहले नॉर्थ पोल के इन्फ्लुएंस में थे वो साउथ पोल के इन्फ्लुएंस में जब जा रहे होंगे तो उसमें ईएमएफ जीरो हो जाए उनके जाने से पहले, लेकिन इस नॉन यूनिफॉर्मिटी की वजह से नहीं हो पाता है।
ओके सर।
जिसकी वजह से स्पार्क आती है। अब तुम समझना क्या होगा इस इफेक्ट ऑफ ब्रश शिफ्ट की वजह से, देखना। अब ये ब्रश शिफ्ट हो गया, सो दिस इज एमएनए ना, मैग्नेटिक न्यूट्रल, ठीक है, दिस इज एमएनए।
ओके सर।
अब इसका मतलब ये हो गया कि हमारा आर्मेचर फ्लक्स कुछ, हमारा रिजल्टेंट फ्लक्स क्या होगा, कुछ इसके परपेंडिकुलर होगा ना।
यस सर।
ठीक है, तो उसका क्या होगा, उसका इस वाले इसका कुछ कुछ इसका ऐसा होगा कंपोनेंट, अगर हम रिजॉल्व कर दें इस मैग्नेटिक फील्ड को, ठीक है, ए लेट से मैग्नेटिक फील्ड हमारी ऐसे आई आर्मेचर की, तो कुछ ऐसा होंगे। इसको इस वाले कंपोनेंट को डायरेक्टली डीमैग्नेटाइजिंग कहेंगे, ठीक है। ये क्या होगा, बीटा ई होगा अगर ज्योमेट्री से देखो तो, ठीक है।
सर आपने जो कंपोनेंट में रिजॉल्व किया वो समझ में आ गया सर। यहाँ जो ब्रश के पास जो हो रहा है उसके बारे में दिक्कत है सर। जैसे आपने बोला पिछले केस में, अगर आप
तो
ब्रश
देखो
का
अब क्या
पोजीशन
है,
चेंज नहीं
हाँ
करते हैं,
हाँ हाँ,
ईएमएफ
नहीं नहीं
इंड्यूस्ड आप।
सुनो, अब ब्रश का पोजीशन अब चेंज कर दिए तो यहाँ पे इस वाली ये जो पोलैरिटी थी इसमें चेंज हो जाएगी।
ऐसा कैसे सर? वो पोलैरिटी तो सर आपका फील्ड के हिसाब से है ना।
सुनो एक मिनट, अब ये बताओ, अब जैसे ये वाले कंडक्टर्स जो थे इनिशियली, हाँ, हमारा लेट अस अज्यूम, हाँ, कि ये हमारी मैग्नेटिक फील्ड थी, है ना।
ठीक है सर।
तो अब हमने जब इसको ब्रश शिफ्ट को ऐसे कर दिया तो ये वाले जो सेट ऑफ कंडक्टर्स जो थे दैट वर सपोज टू बी इन अंडर द इन्फ्लुएंस ऑफ नॉर्थ पोल,
यस सर।
वो नहीं रह जाएंगे नॉर्थ पोल के इन्फ्लुएंस में। उनमें पोलैरिटी सिर्फ इंड्यूस्ड ईएमएफ की पोलैरिटी तो सेम रहनी, सॉरी इंड्यूस्ड ईएमएफ की पोलैरिटी सेम रहेगी, सेम रहेगी, सॉरी, दे आर नॉट गोइंग टू चेंज। दैट विल नॉट चेंज बिकॉज यहाँ पे है ऐसे। एक मिनट देना। साउथ दिस इज अंडर हाफ। induced EMF की polarity will be same, but since you have shifted the brush, huh? Hello.
यस सर, यस सर।
Since you have shifted the brush, the collection of current from these conductors, these amount of conductors will not be same as they were initial. पहले ये सारे कंडक्टर्स जो थे, ये वाले सेट ऑफ कंडक्टर्स और ये सेट ऑफ कंडक्टर्स,
यस
में रुको बताता हूँ। इसमें हो लेट्स से दिस इज, लिसन, अब ब्रश शिफ्ट किए हो तो इसमें अगर क्रॉस है, ये याद रखना कि अगर ब्रशेस पहले पूरे इस पोजीशन में थे, इस पोजीशन में जिस पोजीशन
जी
में हमने दिखाया था, तो ये एंटायर क्रॉस था ना।
जी सर, यहाँ पर लेफ्ट साइड में वही होगा।
ये पूरा यहाँ क्रॉस था, ठीक है।
जी ठीक।
अब हम MNA के न्यूट्रल एक्सिस, दैट मीन्स कि उसके जिधर हम ब्रश शिफ्ट किए तो उसके बियॉन्ड पहले ये पहले क्रॉस थे। अब हम शिफ्ट करने के बाद जब हम किए हैं तो इसकी इतनी एंटायर पे तो क्रॉस में रहेंगे, लेकिन इसके जो बचे वाले नीचे के रहेंगे वो सब डॉट में रहेंगे।
ओके सर।
मेरा कहने का मतलब जो ये वाले अमाउंट ऑफ कंडक्टर्स थे उनको दे विल टर्न इनटू डॉट, जिसकी वजह से डीमैग्नेटाइजेशन एक्शन विल टेक प्लेस।
ओके सर।
क्योंकि ये वाले तो एज इट इज रह जाएंगे। ये रिमेंबर ऑलवेज
सर इनके चेंज होने का कारण सर, इनके चेंज होने का कारण सर।
मैग्नेटिक न्यूट्रल एक्सिस क्या है कि जस्ट आई वाज डिस्कसिंग कि ब्रशेस आर प्लेस्ड अलोंग दिस मैग्नेटिक न्यूट्रल एक्सिस।
यस सर।
मैग्नेटिक न्यूट्रल एक्सिस कहने का मतलब ये हुआ कि फील्ड हमारी एकदम ऐसे है, फील्ड ऐसे है, तो ये मैग्नेटिक न्यूट्रल एक्सिस है। तो ये जितने सारे कंडक्टर्स हैं यहाँ पे, और ये नीचे कुछ 4 कंडक्टर हैं, इन कंडक्टर्स में जो इंड्यूस्ड ईएमएफ है ये पूरा एंटायर सेम पोलैरिटी, सब ये क्या है, इनमें सब लेट्स से दिस क्रॉस है, तो इनमें से ये ऐसे कलेक्ट करके फिर इनमें से होते हुए फिर इस वाले से बाहर जाता है सर्किट।
ठीक है सर।
ठीक है। तो अब क्या हुआ था कि हमने उसको शिफ्ट किया, तो ब्रशेस हमेशा मैग्नेटिक न्यूट्रल एक्सिस पे जाएंगे, भले MNA और GNA अलग अलग हो जाए। पहले क्या था, GNA और MNA अंडर अनलोडेड कंडीशन में कॉन्साइड कर रहे थे, लेटर
सर।
ऑन MNA और GNA चेंज हो गए एज पर द लोडिंग, तो हमने
ठीक
जिधर MNA पहुंचा उधर ब्रश को शिफ्ट कर दिया। दैट
ठीक है
मीन्स
सर।
अब इधर वाले जो होंगे ना, इधर वाले जो पहले, याद
क्रॉस
रखना
थे।
कि ब्रश के एक साइड क्रॉस रहेगा, ब्रश के दूसरे साइड
डॉट।
डॉट रहेगा। तो दैट वाज द पॉइंट आई वाज ट्राइंग टू एक्सप्लेन यू। ठीक है।
ओके
एंड
सर।
this can be easily visualized in a 2-pole machine only. Further, if we go with 4-pole machine, visualization becomes difficult. Okay. So अब मैं ये बता रहा था कि अगर ये बीटा ई है, लेट्स से दिस इज बीटा ई, सो बचा हुआ पार्ट क्या हो जाएगा, 90 डिग्री माइनस बीटा ई।
यस सर।
तो ये क्या हो जाएंगे, ये वाला क्वेश्चन उठा के फिलहाल, डीमैग्नेटाइजिंग एम्पियर टर्न एस्टिमेट द क्रॉस मैग्नेटाइजिंग एम्पियर टर्न। अब बचे हुए टर्न कितने हो जाएंगे? अगर ये बीटा ई था तो हमने अभी देखा ना कि जो बचे हुए थे एक क्वाड्रेंट में कितने होंगे, 90 डिग्री माइनस बीटा ई। तो ऐसे
यस सर।
ऐसे 4 क्वाड्रेंट बनेंगे।
हाँ सर।
तो उनकी अगर यूनिफॉर्मली डिस्ट्रीब्यूटेड हैं तो 360 डिग्री में वो कितने नंबर ऑफ कंडक्टर्स बनाएंगे? अब उसको Z/2, ये टर्न हो गया, पर पोल P हो गया, एंड दिस इज IA बाई पैरेलल पाथ A। याद करना भी नहीं पड़ेगा तुम्हें ये फॉर्मूला, द वे आई एम एक्सप्लेनिंग दिस, बिकॉज अगर लेट्स से ये हमारा MNA है, ठीक है, तो उससे परपेंडिकुलर फील्ड होगी।
यस सर।
अगर ये बीटा ई है तो ये भी बीटा ई होगा।
यस सर।
दिस विल बी 90 डिग्री माइनस बीटा ई। ठीक है, ऐसे समझने की
यस सर।
कोशिश करो। तो सॉरी क्या बता रहा हूँ, क्या तुम हाँ हाँ कर रहे हो? Just try to imagine if we resolve this part, for this resultant magnetic field, this is beta E, then if this is FA D mag, this is FA cross mag, this will be 90 degree minus beta, yes or no?
यस सर।
अब इसके ये कंडक्टर्स और इसके ये सेट ऑफ कंडक्टर, तो ये बीटा ई हो जाएगा, ये 2 बीटा ई हो जाएगा। हाँ, तो ये बचे हुए इधर वाले, बचे हुए इधर वाले, दैट विल कॉज क्रॉस मैग्नेटाइजेशन। अब ये हो जाएगा एम्पियर टर्न क्रॉस, क्या हो जाएगा बताओ, आंसर क्या आ रहा है?
सर 423.11
हाँ,
23
423.11। अब इन दोनों को अगर जोड़ दो, हाँ, इस वाले को और डीमैग्नेटाइजिंग को, तो टोटल तुमको पता चल जाएगा कि 448 हो रहा है। जोड़ो।
जी सर 447.9
तो क्या
राउंड
हुआ,
ऑफ करने।
इसी ब्रश शिफ्ट की वजह से, इसी ब्रश शिफ्ट की वजह से कुछ जो कंडक्टर्स जो शिफ्ट हुए थे, जो मतलब दूसरे पोलैरिटी में फॉल कर गए, हाँ, उन्होंने क्या किया, क्रॉस मैग्नेटाइजेशन, डीमैग्नेटाइजेशन करा दिया, और जो बचे हुए थे वो क्रॉस मैग्नेटाइजेशन तो कराए ही कराए। सो डीमैग्नेटाइजेशन इज इवन वर्स कंडीशन। Cross magnetization can lead to your flux density being concentrated at pole tips, but demagnetization will cause directly reduction in the effective field flux। ओके, अब ये नेक्स्ट क्वेश्चन जो भी है इसमें क्या है, वो सेम पार्ट पूछा है, बोला है कि दिस ब्रशेज आर शिफ्टेड बाय 5 डिग्री मैकेनिकल, सिंस इट इज अ 2 पोल मशीन, तो इलेक्ट्रिकल और मैकेनिकल सेम है, इसलिए
सेम होंगे।
दोनों का आंसर सेम है।
सेम है।
ठीक है, फाइन,
ठीक है सर।
ठीक है, तब नेक्स्ट उसमें मिलेंगे।
तो सर एक क्वेश्चन ले लीजिए आप।
बताओ।
सर बिना जैसे ब्रश शिफ्ट करने पे पोलैरिटी आप चेंज हो रहा है कह रहे हैं,
हाँ,
तो वो बिना शिफ्ट किए भी तो पोलैरिटी चेंज होगा, क्योंकि सर आपका फील्ड डिस्टॉर्ट हो चुका है।
नहीं नहीं, उससे नहीं। देखो, वही मैं बताना तुमको चाह रहा था कि ये जैसे अब लेट से ब्रशेस अगर एज इट इज रह जाते तो पहले वाले केस में क्यों डीमैग्नेटाइजिंग कंपोनेंट्स जी। देखो, एक मिनट, मैंने यही बोला ना, अगर ब्रशेज ब्रशेज एज इट इज रह गए तो ये वाले जितने दिख रहा है ना, ये चीज, रुक जा मैं थोड़ा सा और जूम करता हूँ।
सर ठीक है सर, दिख रहा है, आप बताइए सर।
हाँ, हम्म। अब ये वाले जो कंडक्टर्स थे, हाँ, जो ये सारे थे, जब जीएनए पे ही ब्रश था, हाँ,
ओके
ब्रशेस।
सर।
तो अब क्या हुआ था इस वाले कंडीशन में, इस वाले भी कंडीशन में तो फील्ड फ्लक्स तो ऐसे हुआ था ना, ऐसे आया,
जी सर।
ऐसे गया, ठीक है। फील्ड तो डिस्टॉर्ट कर ही चुका था आर्मेचर रिएक्शन, लेकिन ब्रशेस हमारे अभी भी जीएनए पे ही पड़े हुए थे।
ठीक है सर।
तो मैंने बोला कि इसके ऊपर वाले पार्ट वाले कितने, हमेशा ऐसा रहेगा कि अगर टू पोल मशीन है तो टू ब्रशेस भी होंगे, दो ब्रश हुए तो उसके ऊपर वाले पार्ट में अगर डॉट है तो नीचे वाले पार्ट में क्रॉस होगा,
ओके सर।
ठीक है।
ओके सर।
तो अब क्या हुआ, जब हमने ब्रश को शिफ्ट कर दिया, ठीक है, ब्रश यहाँ आ गया,
हम्म।
ठीक है। तो अभी भी इनमें क्रॉस ही रह गया, जबकि इनमें इसके अपोज इन दो तीन में डॉट आ जानी चाहिए थी, अभी तो क्रॉस ही रह गया ना।
यस सर।
वही कारण बन गया डीमैग्नेटाइजेशन के लिए। अगर इस ब्रश शिफ्ट के साथ इस इधर वाले हाफ वाले कंडक्टर सब डॉट बन जाते और उधर के हाफ वाले कंडक्टर सारे क्रॉस बन जाते, तो देयर वुड बी नो प्रॉब्लम,
नहीं नहीं सर।
ठीक है।
सर ये शिफ्ट वाले रीजन में जो कंडक्टर्स हैं,
हाँ,
उनकी उनमें जो पोलैरिटी है वो जब रिवर्स करती है तब वो डिमैग्नेटाइजेशन के इफेक्ट देते हैं ना सर।
यस।
अगर वो रिवर्स नहीं कर रही हैं
अब
तब
देखो,
केवल क्रॉस मैग्नेटाइजेशन है।
ये वाला पार्ट में अभी भी जैसे अगर हमारे ऐसे सिचुएशन में हमको लग रहा है कुछ थोड़ा सा मिसकम्युनिकेशन हुआ है हमारे एंड से, तुम रुको, ठीक है। ये ठीक है, पहले ये कंडीशन थी, ठीक ना। तो ऐसे कंडक्टर सब यहाँ पे पड़े हुए थे,
जी सर।
ये चार पांच गोला बन, यहाँ क्रॉस था, यहाँ डॉट है,
ठीक है सर।
ठीक। अब
ठीक
हमने
है।
क्या किया, ब्रश तो शिफ्ट कर दिया यार, हाँ, ब्रश यहाँ ला दिया,
ठीक।
ब्रश ला दिया यहाँ पे,
हम्म।
हाँ। मैंने बोला था कि कंडीशन क्या होती, ब्रश के एक साइड, हाँ,
क्रॉस एक साइड डॉट।
डॉट एक साइड हो जाता, ठीक है। तो दैट वुड बी नो प्रॉब्लम, देयर वुड बी नो डीमैग्नेटाइजेशन। यू आर गेटिंग मी और नॉट। स्टिल यहाँ पे दो कंडक्टर, ये जो ब्रश शिफ्ट के बाद एक साइड में इधर ये दो क्रॉस और ये दो डॉट्स पड़े हुए हैं,
सर।
तो उसी वजह से प्रॉब्लम क्रिएट होती है डीमैग्नेटाइजेशन की। अगर यही वो ये ब्रश शिफ्ट की वजह से ये नुकसान है हमारा। और मैं देख लूँगा, हाँ, नेक्स्ट टर्न पे बत पूछना इन केस any doubt persist, because see, one thing should be clarified, अगर मशीन इस फील्ड फ्लक्स जो डिस्टॉर्ट हुआ है, प्लीज फील्ड फ्लक्स डिस्टॉर्ट हुआ है, उसकी वजह से कम्यूटेशन में प्रॉब्लम आएगी। सुनना मेरी बात, फील्ड फ्लक्स के डिस्टॉर्शन से कम्यूटेशन में प्रॉब्लम आएगी, बिकॉज देयर विल बी नॉन यूनिफॉर्म ईएमएफ इंड्यूस्ड इन द कंडक्टर्स, ओके।
ओके सर।
And but cross magnetization and directly demagnetization will be decided about by the amount of conductors uh, bearing dot or cross placed above and below the MNA। अगर यही अभी इस वाले केस में जब हमने ब्रश शिफ्ट नहीं किया था तो देयर वाज नो डीमैग्नेटाइजेशन कंपोनेंट,
यस सर, ओनली क्रॉस मैग्नेटाइजेशन।
हाँ, ओनली क्रॉस मैग्नेटाइजेशन। जब हमने शिफ्ट किया तो देयर द प्रॉब्लम ऑफ डीमैग्नेटाइजेशन केम, इसीलिए हम लोग इन प्रैक्टिस ब्रशेज आर नॉट शिफ्टेड.
ओके सर.
We cancel the effect of armature reaction using compensating and interpole windings. क्योंकि by brush shifting you are actually decreasing the amount of field flux, and that will change upon the direction of rotation, sorry, load, as well as whether machine is a motor or a generator. I hope I am able to clarify your doubt.
सब चीज ठीक ठाक है सर. बस वही एक पार्ट रह गया कि आपने ब्रश शिफ्ट किया तो फिर ये दो जो शिफ्टिंग रीजन में जो कंडक्टर पड़े
हाँ, वो
उनका पोलैरिटी चेंज कैसे हो गया सर? उसका कारण
उनकी पोलैरिटी कहाँ चेंज हुई है मेरे भाई? ये देखो ना, मैं
क्रॉस से सर जो पहले डॉट में थे वो क्रॉस गए ना सर.
हाँ हाँ, अब नहीं, मेरा कहने का मतलब ये है कि वो कंडक्टर, देखो ये ब्रशेज अगर यहाँ रहते, ठीक है, अब मेरा कहना था कि जैसे ब्रश को इधर रखे तो इधर के पार्ट के कंडक्टर्स अगर सारे डॉट हैं तो इधर क्रॉस होंगे, ठीक है,
ये अपने आप हो जाते हैं.
ठीक है, ये अपने आप हो जाना चाहिए, ठीक है. अगर हम लोग एग्जैक्टली एमएनए पे और जीएनए को कौन सा आइडिया, फिर लेट्स से कि हमने ऐसे प्लेस किया है, लेकिन ड्यू टू अभी तो पोल तो हमारा एज इट इज है, पोल एज इट इज है, तो इधर हाफ वाले कंपोनेंट जो हैं दे आर इन अंडर द इफेक्ट ऑफ नॉर्थ पोल, इधर हाफ वाले जो हैं दे आर अंडर द इफेक्ट ऑफ साउथ पोल. बट हमने क्या किया है, ब्रश को शिफ्ट कर दिया है, तो ब्रश के शिफ्ट करने के बाद ये जो दो कंडक्टर्स इधर बचे हुए हैं उनकी पोलैरिटी तो क्रॉस ही रहेगी इररिस्पेक्टिव ऑफ शिफ्ट ऑफ ब्रश. तो मेरा कहने, अब यहां से शिफ्ट होने की वजह से इतने कंडक्टर यहाँ क्रॉस रह गए, कंट्रोल, इतने कंडक्टर यहाँ क्रॉस में रह गए, इधर दो डॉट में आ गए, इधर कंडक्टर इतने डॉट में रह गए, दो यहाँ क्रॉस में आ गए.
ओके सर.
समझ गए?
ओके सर.
ठीक है.